Okay guys, so this is the last of your problems from worksheet number 13. Otherwise, you guys have gone over all the problems, so in discussion alone, you'll have been exposed to 9 Bernoullis, 4 hydrostatics, including worksheet number 14. There should be 2 Archimedes on discussion 14, and 1 drag, so you guys should be well prepared for fluids, but definitely take a look at some of the practice problems, practice tests when those get posted. Go to the review sessions, and then pick out those number 3s from the textbook and do those. They tend to like those for test questions. So in the fluid section, pick out the number 3s and do those. And that alone will get you guys well prepared for the test. The discussions are really just meant to point out, what to look out for. Get you guys thinking in a new way. And once you guys have been exposed to it, you guys tend to catch on pretty quick, and then it's just letting you guys know what to watch out for. But you guys should be well prepared for fluids. And next week we'll do oscillations and waves. The one thing I will say is that I think we kind of we went through chapter 11, I believe it was, a little too fast for my liking. So go over that a little bit more. Pick out some harder problems from that one. Okay, so let's finish up Bernoulli. So this one is meant to give people some understanding of the difference between the pressure and the elevation. The elevation head is what we would call that Z times Q term. So, so you've seen I've put the datum at point number 1, okay? And so that's why the Z1 times Q goes to 0, okay? But that's the only term that goes to 0 this time, because both the tubes are open at the bottom, so both of them have a velocity. Nothing's open to the pressure, to the atmosphere, so none of the pressures go to 0. And Z2 is now elevated. So now when you follow along the path of the path of the particles, and then again, one of the assumptions when you're learning Bernoulli's is that it follows a streamline, and we really haven't gone through that. But he's gonna go, parallel to the flow. And so there we get that Z2 times Q is actually not going to be 0. And I give it to you guys as 0.1 in the problem, I believe. So that's drawn up there. So you guys know Z2. So now what we actually want to find is delta H. So that means that our delta H is no longer the known. And what is known is actually, wait, I got a hiccup. Is actually the Q from last time, okay? So if we look down, let's see, so I'm going to be obnoxious here. So if we look right here, right there, okay, now I'm expressing just in this is hard to do, okay. So just in this part, right there, that's what I was trying to do. I'm trying to express, the V's, which I'm assuming I know because I know both the areas and I'm saying I know the flow rate, and the Z2, which I know, I told you guys, all on one side. But what I don't know is actually the delta P, because I'm assuming I don't know delta H now. And so the delta P's get put on the other side. And if you guys recall so when you see here, you see P2 minus P1 over rho G, but if you guys recall, P2 minus P1 was delta H times rho G. So the rho G's obviously cancel, and so you're left with delta H actually. And so what ends up happening is that if you look over here, let's see, if I do that, then what I'm going to do is I'm going to rewrite V1 and V2 in terms of Q and A, because I'm saying that actually what's not known is our V's, but what's known is Q and A. And so from Q and A we get V, but it's better just to leave, Q was kind of complicated, so let's just, we got Q from problem 8, and we leave it as Q for problem 9. We know A's, they're a little long, and so we just leave it as A1 and A2. We leave Z2, we know it's some number, and then that all of that is equal to delta H, and that's our final answer. So I hope Bernoulli's made sense. I hope you guys enjoyed. You guys seem to catch on pretty quick, so good job.